Hadoop processes. So what we have in a Hadoop before 2.0 and what are the Hadoop daemons which is running on Hadoop 2.0 onwards we discussed, and we discussed what is a big data and what is a Hadoop, how the data is going to be distributed to the Hadoop cluster. So these are the things we discussed on yesterday's session. Okay, so today we'll learn how to access the Hadoop daemons, then how to connect to the Hadoop cluster, right? So whenever we are saying about the Hadoop daemons, the Hadoop processes, right? So we always say the two things, right? So Hadoop generally will have a master and a slave architecture. So we have the master nodes are available, and we have the some slave nodes. So where we're taking the name node, secondary name node, data node, right? Sorry, name node, secondary name node, high availability node, job tracker, resource manager. So all these things we are configuring as the master, and that data nodes, right? In each data node we have a task tracker as well, node manager. So we are taking this as the slave nodes, right? So this is a Hadoop daemons. Now see here, whenever, so when we working, we saying that suppose Hadoop cluster is running, suppose Hadoop is running in a cluster, that in the sense always Hadoop will have the two types of daemons. So we talk like SDFS is running as well as MapReduce is running. That is, SDF is running in the cluster. That means, yeah, the file system is available. So the files in the SDFs are available. That means the name node and then data nodes, secondary name node, high availability node. So these are all together. We call it as a SDFS daemons, which are related to the file system, which are related to the data storage in a Hadoop cluster. So that is Hadoop distributed file system. So now in a cluster, you want to start the Hadoop. That means you have to start the SDFS and then you have to start the MapReduce. So MapReduce here involves in a job processing. So what we have in a MapReduce, we have a job tracker and then a task tracker, right? So where we are going to run the job, the job tracker and task tracker. So we call it as a MapReduce daemons. So then SDFS daemons, then the name node, then secondary name node, then data nodes, if you configure high availability node, right? So these are all known as SDFS daemons. So now suppose it's you have to start the Hadoop cluster. Generally this will be done by the admin. So admin, they will have the privileges to start and stop the cluster, right? So you are going to start the cluster. That means in the Hadoop cluster, then you have to start the SDFS. After that you have to start the MapReduce. So when you start the SDFS, the files physically is ready to available for the processing. Then when you start the MapReduce, we can able to run the jobs, or we can able to run the programs on the data which is available on SDFS. So always a cluster must be enabled with SDFS as well as MapReduce. Suppose I started SDFS here, but I have not started the MapReduce. In that case, yes, I can able to store the files in the SDFS, but I can't able to query the data. I can't able to process the data, right? To process the data, either you have to start the MapReduce or you have to start the yarn. So when about the you're talking about the yarn, so we'll get a resource manager as Hadoop daemon. Then we have a node manager, right? So this comes as part of the yarn. So now in a Hadoop cluster, so you have to start SDFS and MapReduce together to work with the Hadoop, or you have to start SDFS and yarn to work with the Hadoop. Sometimes I'll write some jobs on yarn, but I'll write some jobs on MapReduce. Yes, it is possible in Hadoop 2.0 onwards. We have an option. So you want to run a job with the MapReduce, yes, you can run a job with the MapReduce, and the same time you can run another job with a yarn. So that is in a Hadoop cluster. So you have to start the SDFS, then you have to start the MapReduce, then you have to start the yarn. So now in a Hadoop cluster, so if you are saying about the Hadoop cluster, so always these are the Hadoop daemons, are the Hadoop processes which are up and run all the time. Okay, so now suppose, see here, I'm going to create a directory. Where the directory is going to be created, it is going to be created in a SDFS. I wrote a program. Where the program is executed, the program executed by either if it's a MapReduce is available, yes, it is executed by the MapReduce, or if it is available YAR, it is executed by the YAR. Otherwise, we have a property. So when you configure the Hadoop, so we have a configuration file that is core-site.xml. This is generally we'll get a one configuration file, not code, it's a mapreduce-site.xml. So we have a configuration file. This comes with the installation. In this one, we have an option is there. So mapred.framework.name. Suppose if you specify here the classic, then the job by default runs with a job tracker. Suppose if you write here yarn, then every job executed by the user runs under the yarn environment. So the default execution engine, if you want to specify a default execution engine for the Hadoop cluster, then we need to navigate to the configuration file mapred-site.xml. In this configuration file, so we have to edit the property. So for the property mapred.framework.name, so it will take the two parameters. One is a classic and other one is a yarn. So if you write a classic, then this job runs with a MapReduce, which runs with a MapReduce. Then if you specify it is yarn, then the job runs with a yarn environment, right? So this is the default we can specify. Okay, now see here. Okay, fine, right? So I have started the Hadoop cluster. Now both HDFS and MapReduce yarn is running. Now see here, I'm new to the Hadoop environment and I need to connect to the Hadoop cluster. So think that it is the first day in your office, right? It's a first day in your office and you have to connect to the Hadoop cluster. So when it is the first day, so the first thing is your admin has to create a user with your name, and they will provide you the some privileges to connect to the cluster. And I told in yesterday's session, when you are trying to connect to Hadoop cluster, that means you should able to connect to your name node, because it's the master and all the slaves are the data nodes which are connected to the master, right? So this is a name node, and so these are the slave nodes, that is these are all the data nodes which are connected and configured as a master and slave. So now if you as a user, right, if you as a developer, if you can able to connect to the Hadoop cluster, that means by default we connected to the Hadoop cluster. And here everybody will get a confusion here. When we talk about the SDFS, by taking all the four data nodes together, we call it as an SDFS, not data node 1 SDFS, not like data node 2 SDFS, data node 3 SDFS, right? So what is the cluster size here? 4 data nodes. Now the SDFS together in 4 data nodes, we call it as a 1 SDFS, right? So we don't have a differentiate like data node 1 SDFS 1, data node SDFS 2, right? It's a together, it is called as an SDFS. So the input data which is available in all the nodes, right? So it's specifically it's not available in one data node or another data node. It's available in somewhere in the Hadoop cluster in a data node. So when you say about the SDFS, so this is all about the SDFS. So if a user can able to connect to the name node, then he can able to connect to the Hadoop cluster, right? So here now what we need to connect the cluster. So in a first day in your office, your admin has to create a username. You should have a valid credentials to connect it to the name node. So if you can able to connect to the name node, then you are connected to the Hadoop cluster. So then actually how we connect, right? So consider so this is my desktop machine, which is considered this is a laptop given by my office, right? So think that the cluster is running somewhere, right? I need to connect the cluster. So here I use a putty to connect to the cluster, right? I need a putty, or we have the different tools are available, putty kind of tools, like you can use mobile extern, right? So you can use anything. So here I'm using putty to connect to the Hadoop cluster, right? So now what I need to connect the cluster, I need the host name of the name node or IP address of the name node, right? So if I can able to connect to this cluster, so by default I can able to connect to the all the data nodes together in a cluster. So I need this one. So generally your admin will give you this one. So how to get that one? So if you run the command here, we have a file in the Linux file system that is in a directory etc. Under that we have a file host. If you if you see this file, we can able to see the host names, right? So these are the host names which are available for the Hadoop cluster. So generally this is going to be the host name, right? And see here, most of the times this host name is it's a naming convention which is related to your business client business name, right? Suppose if you're working for the Bank of America, right, then the naming convention something should be like this. You'll find it is. So the host name contains always the name of the business. So most of the time, suppose if it is a Bank of America, BOA dot, so cluster one com, right? Something like we'll have the host name. So we use the host name to connect to the Hadoop cluster, and every machine is enabled with an IP address. So we need an IP address to connect to the cluster. So if you run ifconfig, right, so this is the IP address for the name node. So we need these two things. We need a host name to connect to the Hadoop cluster, and we need an IP address to the connect to the cluster, right? And we should have the privileges to the connect to the cluster, right? So now think that the cluster is running somewhere, right? So I'm in this my desktop which I'm trying to access the cluster. So I've started the putty. Now I need to know the this one, right, IP address where the name node is configured, right? So here write the IP address and click the button open, right? So now I have started a terminal which is trying to connect to the Hadoop cluster. So here you have to enter the password and username. Generally this will provide you your admin, right, my user. So here the default one, if you're using the Cloudera, so the default username is a Cloudera and the default password is to Cloudera, right? So now right now in a Hadoop environment, so now I have connected a Hadoop cluster, right? So then I can see here I can run Hadoop space version to know the Hadoop version, right? So I have able to connect to the Hadoop cluster now. And the same thing we use putty to connect to the Hadoop cluster, as well as we use the browser to access the Hadoop services, right? So in the browser, uh, right, so what we have to do, we have to write the host name, our IP address. Then if you write 50070, will give you the name node information, right? So what I did here, I wrote the host name colon the name node WebUI is the 50070. Simply you have to write the host name. So or you have, if you are otherwise, write the IP address, then colon, then write the name node WebUI. This is the same and unique number. So most of the Hadoop clusters, most of the clients will use the same number, right? So they won't change. So by default it is a 50070. Will be able to see the Hadoop cluster information here, right? See now what I did here. So to access this one, first I have connected putty to the cluster. So to query the data and to see the cluster information, so what I did, I entered the host name or the IP address of the name node colon 50070, which is a name node WebUI, where I can able to see the information about the Hadoop cluster. Now you can see here, so I wrote this one colon 50070. Now I got the Hadoop cluster overview. See now this is the host name of the Hadoop cluster, and the name node is configured on a port number 8020. So here don't get confused here, 50070 is the WebUI port and 8020 is the port with where name node is assigned, right? So don't get confused with the 50070 and 8020. We use a 50070 is a UI to access the name node in a browser. So it is known as a WebUI port, and this is generally the port which name node is assigned. That's 8020, right? So now we can see this, the name of the Hadoop cluster, host name of the Hadoop cluster, and its port number. Right now the client, the cluster is active, it's running now, right? You can see the when the cluster is started, right? So you can see the cluster information, right, number of blocks and the size and how much you configured here, right? That storage about the cluster, we can able to see anything. Now see when the Hadoop is right now you can able to connect Hadoop cluster. Now you want to know how many data nodes are there in Hadoop cluster. So what is the size of the data nodes in a cluster, right? You want to know that. Then if you scroll here, you can see the two options. One is the live nodes and the dead nodes. So live nodes are the nodes which are up and running. Dead nodes are the nodes which are connected but which where it's not identified by the name node, right? So that's we call it as a dead node, right? So the dead nodes are 0 and live nodes, the data nodes which are connected to Hadoop cluster right now. So if you click this, you'll get the live nodes. Right now I'm having the one data node. So this is the host name of the data node, and this is the IP address of the data node. Right, so now we can see, suppose if the cluster is having 10 data nodes here, so it will list all the 10 data nodes name. So each data node host name and the IP address of that particular data node, and the how it is available, it's in a service or not, then the storage information will be displayed here. So how many data nodes are there, all the data node names and IP address are available. So like this, now you can able to retrieve the Hadoop cluster information. Right, so now you don't need to ask somebody, someone in your office, how many data nodes are there, how much configured, where Hadoop stack is available, where they configure this cube. Right, we can able to locate by going through like this. Suppose, see here, consider right now I'm having one data node. Right, so one data node in the sense, now see here, this one, this is the data node. Right, so this is the data node. Now I can able to connect to the data node, but I can only access the local file system, but I don't have the privileges. Not even an admin also cannot able to access the SDFS file system. So the SDFS can be accessed through only name node. Just remember, so we can connect to a data node. It's possible we can connect to data node, but the limitation is we can access only local file system. We can access only local file system. That means the files which are related to the OS. Because suppose if you can't able to connect to this one, then how you configure the new components? How you, suppose I have added a new data node, then I have to install the Hadoop. So to install Hadoop, I need to connect to that machine, right? So that is the thing. So we can able to connect to a local file system. We can able to connect to a data node, then we can able to access the local file system here. But the user cannot able to connect to the data node. So you do not have the privileges to connect to the data node. So it's not possible to connect to the data node. Sorry, not possible to connect to the SDFS. Even a developer or an admin, nobody will have. Even if you can able to connect, but you can't able to see the data. Here all the blocks are written to a single file with the name some block full, so you can't able to do anything with that, and it's hardly unable to locate the data. So now to access the SDFS, always user has to connect through the name node, and if you connect a data node to access the SDFS, it is not possible. Right, so now here I have given a job. Now my manager told me to configure some new component. So my told me to configure some Hive or some Scoop in data node 2. He told me to install some MySQL in data node 2. Then, so what I need to do now, I need to connect to this data node. Then I have to go to the respective directory. Then I need to get a tarball and I have to install it. So here, that means I should be able to connect to the data node. So how we connect to data node? So this is the data node 3, right? So what is the data node 3? And we should get the host name and IP address of the data node 3 from this page. Now you take this IP address, right? So this is IP address of the data node. Then so I have to configure right here. So I'll use a SSH, right? I'll run the command SSH space, then write the data node names IP address which you are trying to connect to, right? Then press enter. So it will ask the password to connect to that particular data node, because you should have the privileges. So if you have valid credentials to connect to that cluster, then you can able to connect to. So I have connected to the data node now. Yes, now I can access the local file system. So if I want to configure something, then you can go to the directory of that particular home. Suppose here, now you can install whatever you want. Right, so like this we can able to connect. I want to run a job in this data node. Yes, you can run a job. Suppose I want to run a query in SQL or Hadoop. You can connect user lib here where we have a Hadoop ls, right? So this is the Hadoop files available in this data node. We can able to access that, right? So like this we can able to connect to individual data nodes too. But when you connect it to a data node, you have an access to a local file system. but we are doesn't have an access to the SDFS, right? So that is again, it's a simple reason. The SDFs in the sense all the data nodes data together SDFS, not this one particular SDFS. So we cannot differentiate this data node SDFS, this data node SDFS. The SDFs in the sense it's the SDFs in all the data nodes. Okay, so like this now we can able to connect to the data nodes, right? So fine, now we now I know that how to connect to a name node and how to connect to the data nodes. Fine, so where you are trying to configure or you want to run a job, so you can directly connect to that particular data node. When we can access the local file system, we can install as well as we can submit a job from that particular data node, right? Now see here, I want to access the Hadoop Daemons. Now I want to see the information about, so what are the jobs are running in Hadoop cluster, and I just want to know the information about the SDFS, right? What are the files are available in SDFS? So we have different WebUI ports are available. So it is very important, and every Hadoop developer who is working with Hadoop should remember these numbers, right? You have to remember these numbers, right? So that's a, we call it as a WebUI ports. So here we use to write the host name first, or you can write IP address colon. Then if you write 50070, where we are going to access the name node, right? So you can able to see the information about the name node, right? Suppose you want to see the data nodes. So the data nodes, that's a 50075 is assigned to the data node WebUI. Okay, so you want to see the status about the job tracker, information about the job tracker, then you have to start, you have to open 50030, where it will display about the job tracker, right? You have to remember these numbers, right? 50060, these are the numbers mostly unique for every client, right? Every cluster. So 50060 for the task tracker. Okay, and then 50090 for the secondary name node. It's 50090. And after that, so if you want to try to access the yarn, then we use 8088. It's for the yarn, right? Where we can see the yarn web UI. It's 8088, and I want to access the Hadoop cluster through graphical user interface. I need a GUI kind of environment. Then we have Hue is a one component which is available, which runs on the port number, the WebUI port, that is 8888, where I can access the Hadoop stack through the graphical user interface. Now I'm going to show you this. Open a browser, then write the host name. So what is the IP address? Now, right, I can see the 50070. Now I have connected the name node. To connect to the data node, right? So what we have to do? We have to type 50075. And remember what I told, that we cannot able to connect to the data nodes to access the local file system. Now I'm trying to access the data node through 50075. See here, right? I cannot able to access, right? It doesn't display anything. It's an empty data node, empty information, right? So like the users doesn't have an access to connect to the data nodes directly. Then how to see the data in SDFS? Now I want to check that what are the files are available in SDFS. That's the thing, right? So we have to connect through the name node. So first connect to the name node of WebUI. So here you have to choose the option browse the file system. So when you click the browse the file system, then you have connected to the data nodes SDFS. Now, so these are the files which are available under the SDFS Hadoop file system. Now the users files. So if you create a directory or if you copy a file to the Hadoop cluster, by default that will be written to user Cloudera, right? So this is the default location for users directories and files. That is something. If you write exit, right? So if you write Hadoop space fsmkdar, then I'm writing new T. right? A directory is going to be created with the name new t, right? So I'm going to create a zero empty file, zero size file with the command touchjet, right? So it's a touchjet is a command will create some temporary file with a zero size, right? I want to create a file in the directory new t, that is zero empty file zero, right? So I created directory new t and is having a file zero. Now we can access the same from here, right? You want to see that? Then by default, so I didn't specify the path here. See, did I specify the path? No, I wrote the directory name. So by default, user files and directories are created under user Cloudera. The default location is user Cloudera. So if you go here, uh, now you can see the directory which we created, that is a new t. See now, this is a new t which is created just now, right? If you click here, now we can see a file with the name file 0. It's an empty file, right? So like this we can able to access the SDFS. But internally when you write this file, right, when you write this file here, so the file is going to be divided, then replicated blocks are distributed blocks are placed into the data nodes. But when I'm trying to retrieve, so all together blocks will be displayed as a single file to the user, right? So like this we can able to access the data node information, right? And we can see the data node through only name node. We can access the SDFS through the name node. So here in the utilities, you need to click the browse the file system. So we have the different directories are available. So here by default user Cloudera is the default location for user directories and files. So here the directory which is created by user, you can find here and you can see the files where we are going to access this through the SDFS, right? So like this we can see the name node and the data node. Now you want to access the job tracker. Now job tracker is available on 50030. So we need to know the IP address, right? So 131 colon job tracker is available on 50030, right? See, I cannot able to connect to, right? So let me try with the task target, right? It's 50060, right? So can I able to connect to 50060? No, right? Now we'll see the secondary name node 50090. Just write 50090, press enter. So 131, sorry, 131 colon 50090. Okay, now see we can able to see the secondary name node. But now can we able to connect to the job tracker and task tracker? No, because there is no job tracker and task tracker is running in the cluster right now. SDFS is available, so I can able to access the SDFS daemons. Now here yarn is available. To access the yarn, then write 131 colon it's 8088. Now I can able to access the yarn. So now here I'm not using the map reduce. Instead of that I'm using the yarn, so that I can run a job under the yarn environment, and all the jobs which are executed under the yarn execution environment. Right here I can able to see the information about the yarn. So the yarn which is configured, the cluster information is available here, right? So resource manager is started, the resource manager available state is active, right? And this is a version which I'm using. Now it's ready to take the jobs from the client. And you can access the graphical user interface through the Hadoop WebUI, that is 8888, right? So we can run through graphical user interface. Now here username, click here, that is a default username is a Cloudera, and the default password is a Cloudera. Click the button sign in. Now see here, I have connected Hadoop cluster through the graphical user interface, where I can run access everything. I can write Hive, as well as I can write a pig. I can browse the file system and see these are the different options are available which we can run as a GUI, right? So like this we can able to see the information about the Hadoop daemons. Right now name node in the data nodes, no job tracker and task tracker is running here, and the secondary name node, and it is a yarn, it is a hue, right? So these are the web UI ports, right? So just try to remember these numbers. How to get the data to the Hadoop cluster, right? So I have already given a brief on yesterday in the previous session, right? So the same thing here we call it as how to ingest the data to the Hadoop cluster, right? So we have the different ways to get the data to the Hadoop cluster, because if you're trying to process the data, right, if you're what we are doing in a Hadoop, the thing is what we have given a data and we have to process the data, right? To get the data to the Hadoop cluster, so we have the different ways. Here we call it as a ingestion, data ingestion, right? So we have the different ways to load the data into the Hadoop cluster. So in this one, yeah, by default this comes with Hadoop, that is Hadoop file system API, right? So we have Hadoop file system API, which provides some shell commands, Hadoop commands, where we can able to copy the data from a local file system, from a Linux file system to the Hadoop cluster. So the one way of ingesting the data Hadoop cluster is, so we use Hadoop file system API, right? So which contain some set of commands, and in the previous versions, right now we are not using, but previously we used to have Java API, right, where we can able to write the data to the Hadoop cluster. So we have available input data is available somewhere, then we can use a Java program, so that if you run the Java program, so it will create an output file, right? We have to specify the target location, so we can create a file, we can append the data to an existing file. So that's we are used to do that with the Java API, but right now, so we are not using, it's a completely depreciated, but it's a one way we are going to ingest the data to the Hadoop cluster. And then the third one, so if your data is having in a production database, right, so the data always here, the particular word is a production database, right? So then we use a component scoop, right? Scoop, that means it's a simple, it's a SQL plus Hadoop, we call it as a scoop, right? So we call it as a scoop, right? SQ, and it's a OOP, that's a scoop, right? So we use this component which particularly which imports the data, which transfers the data from the database RDBMS to the SDFS. So it performs the data transfer. You can run both import as well as exporting the data between RDBMS and SDFS through a component scoop. So we use one component scoop to ingest the data to the Hadoop cluster, right? Then you can use Flume here. So the Flume is one component, right? So where we have the data is available in a servers, or you can say network attached storage machines, right? So we ingest the data, or we sync the data to the Hadoop cluster, right? That is a Flume. Apart from that, so if I want to stream the data, I want to ingest the real-time streaming the data, then we use Kafka, and then we use Star, right? So these are the streaming tools which we use,
So
right?
Ajay, you will give the each and every example, right?
uh,
And
Not everything, the specific, suppose I'll teach you the Flume, right? I'll teach you,
uh,
I'll show you, not that is, I'll run by an example of
okay,
how I use the Flume to write the data to the SDFS, and I show you the example of how I use the Flume to write the data to the NoSQL database. And if you need, then I'll give you one session on Star. If you need Spring XD, I'll teach you. It's an avail requirement, and all these things are the small documentation, so it doesn't take much time.
okay,
But if you need it, if you want, I'm going to teach you that one, so it doesn't take much time for me. So anyway, I'm going to show you one example at this end, so how I use the Star to get the real-time streaming the data to the Hadoop cluster, right? I'll show you, it's all the streaming tools and the same thing, right? But the way how we are writing is the different, but the internal method which we are using is the same. Okay, so I'll teach you
okay.
that one. right? So these are the so different streaming tools are there where we are going to stream the data. Actually, so the previously we don't have this OLTP kind of thing here. Suppose the issue arises such a way when if you take a financial client and a banking client, but even see till today, but most of financial and banking clients not turning to the Hadoop because the security concern here. So apart from that, for certain kind of fraud analytics, right? So to be identify the people, so they are using the Hadoop, but not complete integration. It's basically financial and banking clients are less, and so there is a heavy usage. The people, the clients, particularly retail and healthcare and manufacturing. So there is a heavy implementation of Hadoop. Almost every healthcare the client, so they are implementing Hadoop, and the retail business they are implementing Hadoop, and manufacturing, right? So they are using Hadoop, but less Hadoop, especially for the financial and banking clients. Okay, so here why I'm saying this, generally I'm having issue. Somebody's try to access your bank password, so there are the two wrong password attempts. Actually what the bank has to do, they have to call immediately, right? So when the second wrong attempt password, so in the third minute, so you should be given information, somebody will call you and is trying to access your password. But generally what happens, so when there is the two wrong passwords, I'll get a mail the next day, and then the bank person will call the next day, yesterday somebody will try to access. Then my question is, then why didn't you inform immediately, right? So that's the thing what I need to know. As the transaction occurs, right, all the two transaction fails immediately, that should be reported to the respective person, and that should be given to the another person, and you should get a call in a simultaneously immediately in a next minute, right? So that is the OLTP. Now right now with the Hadoop, when you have these streaming tools, so we can make that thing possible, right? I use a Hive program such a way that first Flume will or Kafka or Stump, it will stream the data to the SDFS. Then I'll run some validations on a Hive, and I will send a mail to the team, and the team will the particular team employee, the person will send a mail to your bank manager. From that you may get a call in the next 5 to 10 minutes. Right now it's going to do that. So it's possible with the OLTP is possible right now with the Hadoop, right? So this is a Flume, we can able to stream the data, and we can able to configure FTP file transfer FTP client to upload the files to the Hadoop cluster. So if you have the data not in a server, not in a production database, my is having some disks are there, or my some having the desktop machines, or my application is generating a lot of files like XML files, Excel files it is generating. Now I have to upload those files to the Hadoop cluster. Yes, you can use a FTP. Through FTP we can able to upload the files to the Hadoop cluster, so we can run an FTP client. And the sixth one, see here I'm having the two Hadoop clusters, right? So my client is having one old cluster and the new cluster, right? I want to copy the files, I want to transfer the files from one Hadoop cluster to another Hadoop cluster. So we have one utility is there, that's a distcp, right? So which completely stands for distributed copy, right? So we can use distcp to ingest the data to the Hadoop cluster. Right here the thing is what, so what will be the source, one name node, and where we are reading the data, where we are ingesting the data, another data node. So distcp will copy the data, will transfer the data between the Hadoop clusters, right? And apart from this, so we have Hue and Ambari is the GUI environments where we are having the file browser. So we are having a file browser option here, and with this we are going to upload the files to the Hadoop cluster. So like this we are ingesting the data to the Hadoop cluster. So these are the different ways we can ingest the data to the Hadoop cluster. So in every interview, suppose you are taking an interview or you're attending an interview, the first question is you're working for some project. When you're working for some project, you need to get the data. So my question is either interview I'll ask, so how you're getting the data, or I'm the person who is attending the interview, I need to explain so how I'm getting the data. So in both the ways, every user should know this one, and this is going to be the topmost. So almost every interview you find this question, right? How you're collecting the data, how you are ingesting the data, or how you're getting the input data to the Hadoop cluster. So every Hadoop project has to use anyone from these to get the data to the Hadoop cluster, right? Once the data is available, now we are going to proceed. Now, so these are the different methods where we are going to write the data to the Hadoop cluster. Okay, so I'm going to show you this one. Right, so we learn the file complete set. I'll teach you each and every command with all the possible parameters here. Then we'll learn Scoop, then I'll teach Flume, and I'll teach Kafka or the Spring XD to you. Then I'll teach, it's a FTP, it's very easy. These are the small things we can learn. Okay, so any, right, and the file name is flight delay, and I want to copy this file to the directory, new T, press enter. Okay, now you can see now the file is available here. You can see Hadoop space fs-ls new T, press enter. Right, we got a flight delay, and we can also access it through SDFS here. So browse the SDFS, then just refresh it. Right, see we got a file under user clutter new T. So this is a file which I have created, flight delay. Right, so like this I can able to upload a file to the Hadoop cluster through through FTP. Right, so when we configure the Hadoop, right, so that is Hadoop is a combination of SDFS and MapReduce or SDFS and yarn, right? So when you install Hadoop, we'll get the Hadoop configuration files. So one we have with the name core-site.xml and SDFS-site.xml and mapred-site.xml. So if you are using yarn, then it's a yarn-site.xml. So these are the configuration files we'll have for the each hand Hadoop daemon. And apart from that, so we have an environmental file with the name hadoop-env.sh is a environmental file. So now if you see the core sdf7site.xml, so what it contains, this file contains the configurations related to, it contains the configurations related to SDFS. So like the block size, the replication factor, right? So those are the properties, like the properties which are related to the name node, data node, secondary name node. So they are all written to this configuration file SDF7 site.xml. And what is the mapred-site.xml contains? So it contains configurations related to MapRed daemons like
Job tracker.
job tracker and the task tracker
Job
configurations
tracker.
you can find in mapred-site.xml. Then what we find in yarn-site.xml, so the config relation related to resource manager as well as node manager, right? So these are written
Application
into,
master. Right?
yes, right, resource manager and application master together is a resource manager.
Oh, resource manager. Okay.
Right, so both together is a one job, one role, right? Resource manager and application master together called as a resource manager. So these configurations are related to yarn. Then what core-site.xml contains? So the core-site.xml contains the common configurations for both SDFs and MapReduce, right? So it contains common config for both SDFS and MapRed. Generally, what are the common
So it's the same
configurations?
information. It's the same information that are in other two files.
No, the common, see, we have some
Oh, the
common
common one.
properties. The log location, right? Either it can be SDFS or the MapReduce. The log file location is the same thing, right? So the log location is a common property for SDFS and MapReduce and yarn. So the common configuration for all the Hadoop daemons are written to core-site.xml. So the log location, you can see the temporary file location, right, are the trash available to recycle bin location, right? So like these properties are written to the file core-fn set.xml. So you should able to identify whether this property related to SDFS or whether this property related to MapReduce or this property related to the YAR or this is a common property for all the Hadoop daemons. So if it is a common property for all the Hadoop daemons, then you have to navigate to the core-fn set.xml. And if it is a property which is related to storage or SDFS, then you need to navigate to the SDF7 site.xml to change the configurations. If it's a MapReduce configurations, you related to job tracker and task tracker, So you have to navigate to the mapper-cited.xml. Where do you find these files? So generally in the Hadoop home. So Hadoop home in the sense, so from where you configure the Hadoop, so that is a Hadoop home, right? So you can see if you work in a Cloudera as Hadoop, so by default you can find these files under user lib. Under user lib is the Hadoop we can find here. So this is the Hadoop home in a Cloudera. So it's a Cloudera. This is the location, right? So in this one, we have an etc directory. We can find the configuration files, or we have sometimes we can find these files in under etc Hadoop conf. So these are the two locations where we can find the configuration files in Cloudera. Suppose if you work with the Hortonworks Hadoop, right? So if you are in Hortonworks, you're working, then you can find these files under usr, and then you have a directory sdp. Under then you have the version of the Hadoop, sdp version. Under this, right, under this user sdp 2.x, so here you can see the Hadoop. Then here you can have a kind of directory, so where we can see the configuration files if you work in a Hortonworks Hadoop. So if it is a mapper you're working, then you can find this under /opt and Hadoop, right? So here in the conf directory we can see the configuration files. See here, it's a Cloudera I'm working now, so I can find this here, clear the screen, cd /usr lib, then Hadoop is the Hadoop home, right? So where I can see all the Hadoop configuration files here. So Hadoop directories are here, so you can see bin the binaries, and the configurations are available in the conf directory. So if you navigate to cd etc, then Hadoop ls here, so now you can see the configuration files: core-cited.xml, sdf-cited.xml, mapper-cited.xml, and then yarn-cited.xml, right? So these are the configuration files. Now you can edit with the vi, so core-cited.xml. Now we can see, so these are the configurations which are common for both the sdfs and the MapReduce, right? The same thing. Now you can see the sdfs-cited.xml, right? So this is sdfs. Now you can see here the sdfs configurations, right? And if you write mapred, right, so this is a mapred -site.xml. Now you can write the configurations related to mapred here. You can see here mapred.framework.name I told, no? So what is the default execution engine you want to use? So if you write classic here, then the job by default runs with a MapReduce. So here I wrote a yarn, so the job by default runs with a yarn execution environment, right? So that is a yarn, right? So these are the Hadoop configuration files, and then we have one file is there with the name hadoop-env.sh. So what this hadoop-env.sh contains? Okay, so hadoop-env.sh contains the environmental properties. So right, that is suppose now you don't know where the Hadoop is configured, or where MySQL is configured, where Java is configured. So all the Hadoop homes, right, Oracle home, Java home, right, MySQL home, whatever the components you configured, what are the applications you configured, you want to locate the paths. So all the paths are written to hadoop-env.sh. So now we can see the Java path here, right? So where Java is configured, so where MySQL is configured, right, where Hadoop is configured. So all these are written to this hadoop-env.sh. So we call it a environmental file. So you can see in the same place, escape shift q. can see here under the etc that Hadoop. User lib, then Hadoop, and then etc Hadoop. Now you can see here ls vi Hadoop -env dot sh, press enter. Now you can see the environmental. So where the Hadoop mapper is configured, the location, right? So where the Hadoop is available. So all these parts you can write into this configuration file. The Hadoop home, MapReduce home, Java home, Oracle home, right? So will be written into this environmental file. Okay, so this is Hadoop configuration files. Now you can generally what we'll do now. So these files doesn't have, we don't have the privileges to access those files. Generally the files will have comes under the admin privileges. Okay, so this is Hadoop-env.sh. Okay, so fine. So right, so this is about the Hadoop configuration files. Now it's either can be a Cloudera or it can be Hortonworks, it can be a mapper. But because the properties are the same thing, either you are going to work with an SDFS, so it can be any Hadoop distribution, right? So the Hadoop daemons are there, but except the mapper doesn't have a name node, right? Just remember both if you are working in a Cloudera, see here, just try to remember this. So we have the three different vendors are there, that is a Cloudera, right? So the Cloudera, they are using SDFS to file system to store the data, and then we have both MapReduce yarns available, right? So and the developers, you have a graphical user interface with a Hue file system, and the administrator, they use a Cloudera manager to administer the Hadoop cluster. So this is admin utility to administer the Hadoop cluster, Cloudera manager, right? So they have name node as well as data node is available. Then if you work with Hortonworks, okay, so Hortonworks will have the file system SDFS where we are going to store the data, and they don't have the Hue,
Somebody,
right? So they are using Ambari, right?
somebody.
So the GUI is available. Ambari for the developer version is Ambari is available, and for the Ambari for the admin version is available, right? So both will have the privileges, right? It will be different. So you developer will get the developer privileges to access the Hadoop cluster, so admin will get the admin privileges to access the Ambari, right? So this will provide the GUI. And in the Hortonworks, Ambari is available from the 2.3 onwards, right? From SDP 2.3 onwards we used to have Ambari, right? Before SDP 2.3 we used to have Hue in the Hortonworks 2. Before 2.3, so we used to have Hue in the Hortonworks 2, right? And the file system is SDFS. And when you work for the mapper cluster, here's the difference. So they don't have the map SDFS file system. Mapper uses a mapper file system. So they have a file system mapper FS. Okay, so the file system is mapper FS, and they use GUI Hue for the developer, and for the admin they use MCS. MCS stands for Mapper Control System. It is a Mapper Control System to administer the Hadoop cluster. And then right, so the file system is Mapper file system, GUI is Hue for the developers, for the admin MCS. And you just find one difference here. So Mapper doesn't have a no name node, so there is no concept of the name node here. So they write the data into the secondary storage. That's the difference in a Mapper cluster. Okay, right? So in tomorrow's session, so we will discuss the first one, how to work with the Hadoop file system API, right? I'm going to teach you the how to work with the Hadoop environment. So I'll teach you this one, and meanwhile I'm going to show you how to run a job in a Hadoop cluster. So we'll do the two things: how to submit or how to run some test job in a Hadoop cluster under yarn. So by default I'm having the yarn here. So in yarn environment, how to run a test job in Hadoop cluster. I'll show you this one, and we start with the Hadoop file system API, where we discuss the Hadoop, how to work the Hadoop environment. That's a Hadoop API commands. Fine. So okay, any queries? Rakesh, Rohan, Rohit and Siddharth.
No, fine. So I think you already mentioned right earlier, just to revisit for myself. So Mapr will give 100% high availability, right? Only
Yeah,
Mapr.
no, actually right now all the Hadoop distributions are giving 100% high availability, but from the day one into the Hadoop business, even before 2.0 to Mapper is
Mm-hmm.
giving 100% high availability, because see, if it is a cloud and Hortonworks, the name node, they are writing the metadata in the name node. They are writing into name node's primary memory. Right, so that's the reason name node is a single point of failure in a Hadoop cluster. So if name node goes down, you're going to lose the metadata. When you lose the metadata, you're not going to locate the reference in the data nodes. So the entire cluster is you cannot use that one. But Mapper, what they did, so whatever the metadata you're writing in the name node, they are writing into the secondary storage in somewhere into the disk. Okay, so if that goes down, but we can able to retrieve the data. And they'll have the secondary storage disks are there, they configure for the name node. So from the day one, only Mapper is giving 100% availability, but right now the Cloudera, Hortonworks and Mapper, so they'll give full high availability now.
Okay. Yeah. Thank you.
Okay.